For two students, we are going to identify possible rational zeros of polynomial functions. We've just been identifying whole numbers as of now and imaginary numbers. So we want to find all rational zeros of a polynomial function. That's what we want to do in this video. And I'm just going to show you one example of how to use this. Feel free to watch Mr. Edgley's video and see other examples, and please come with questions in class, because we're going to be practicing this in class. So the rational zero theorem, it means that if p of x is a polynomial function, so you have this polynomial, then every rational zero of p of x equals 0 in the form of p over q. So rational means fraction, okay, where p is a factor of the constant term and q is a factor of the leading coefficient. So what you're going to do is take all the factors of you're going to take all the factors of your constant over all the factors of your leading coefficient. And that's how you're going to get your possible zeros. Now, all of them are going to be zeros, but there's a possibility. So let me show you what I mean by the rational zero theorem. So let's use this example. Q is going to be 4 here, and P is going to be 16. So let's list all the factors of 16, our P here. Well, 1 goes into 16, plus or minus 1, right? Because you could do negatives, 2 negatives equal positive, so we got to include our pluses or minuses. Plus or minus 2. What else goes into 16? Plus or minus 4. Plus or minus 8, and then we have plus or minus 16. Okay, so that's our numerator. And then our denominator, our q, is going to be our 4. So what are all the values that go into 4? Plus or minus 1, plus or minus 2, and plus or minus 4. So what are all our combinations then? Well, 1 divided by 1, so we know we're going to have 1. And then I just kind of go down the line here. We know we're going to have 2, plus or minus 2, right? Because we're dividing by 1. I'm just thinking of all the combinations. We have 4 divided by 1, plus or minus 4, 8 divided by 1, okay, and 16 divided by 1. So we have all those. 2 divided by 2 is 1. 2 divided by 4 is a half, so we're going to have plus or minus a half. And let's see, now it's going to 4. 4 divided by 1, we got those. 4 divided by 2, we got those. 4 divided by 4, we got that again. Let's see what else. Now let's move on to 8. 8, 4, 2. Very good. Oh, we forgot to do this part. 1 divided by 4. Forgot to do my ones. So 1 over 1, 1/2, and 1/4. We get that. So we got to have that 1/4 there as well. See if I can shift some things over. So you got to kind of go in order here. And it looks like all of them are covered then. Sound good? So that's listing all the possibilities. Now, what do we do with these possibilities? Well, these are going to help us find those factors that are in between the whole numbers, okay, like these fractions right here. So we know how to, if it crosses our x-axis, we know how to do that when it crosses it at a whole number. But what happens if it crosses it at a in between the whole numbers? That's where these come in handy. This helps us decide which ones we want to choose. So this is the example we're going to use. 6x cubed plus 5x squared minus 9x plus 2. So let's go ahead and list out all of our factors. So remember, P is going to be 2, and Q is going to be our 6. Q is going to be 6 here. So factors of 2 are going to be 1 and 2, plus or minus. And then factors of 6, let's see, we have 1, we have 2, 3, and 6. So now our possible factors, if we go down the line here, We could have plus or minus 1. I like to get those whole numbers out of the way. Plus or minus 2. So those we have all divided by 1. Now let's get our fractions. Looks like we're going to have 1 over 2 plus or minus a half. We're going to have plus or minus, looks like a third, plus or minus a sixth. Okay. Now let's move on to the 2's. 2 over 1, we got that. 2 over 2, we got that. 2/3, plus or minus 2/3, we need that. And then 6, 2 over 6 is a third, so that's covered. So which ones do we choose? We don't have time to choose all of these. Which ones do we choose to start out with to see which one's a factor? Well, we got to go to our graphing calculator or Desmos, and we can pick some. So it looks like all of our fractions were in between 1, right? Half, third, sixth, and 2/3. In between 0 and 1 or 0 and -1. So let's look at our graph. So it looks like it has to be somewhere in here. Okay. Now, could you zoom in? Sure. To see what it's close to. Okay. It looks like we might want to choose not a half. We might want to choose maybe the 2/3 of the third, right? And Desmos kind of really helps you out with that. So let's say, let's just say I'm going to try a third, a positive 1/3. So when I do that, I'm going to use synthetic division, and I should get 0 as my denominator if it is a 0, if it is a root. So it looks like we have 6, and then we have 2, which is 7. And then 7 times a third is like 2 1/3. So that's a -6 2/3. Do I even need to keep going? Is that going to be 2? No. So this one does not work. So let's try 2/3 now. And again, the closer you can zoom in, the better on your calculator to help you decide which ones to choose. So it's kind of a process. You got to be patient. You got to have a little time here. You got to have a little time. So bring down the 6. 2/3 times 6 is 4. Then we have 9. Then 2/3 times 9 is 6. So we get a -3. 2/3 times a -3. It's a -2. All right. So 2/3 works. So let's start there. So we know 2/3 is one of our zeros. Now we can go ahead and factor this. So we have 6x squared plus 9x minus 3. Go ahead and use T method right now, but can't we just go ahead and factor out a 3 to make our lives a little bit easier? Let's factor out a 3. So we get 2x squared plus 3x minus 1. Now can we factor this, the 2x squared plus 3x minus 1, using the T method? Let's try the T method. 2 and 1. Let's see, both of these have to be, or one of them has to be negative, and it has to add up to a positive 3. So does that end up working out? I don't think it will. -1 and 1? No, it won't work out. So what do we do when we can't use the T method? That's right, we got to use the quadratic formula. So that's what we're going to do to find our other two answers. So it's a -3 plus or minus 3 squared minus 4 times 2 times a -1 all over 2 times 2. So that's going to be 4. Sorry, I'm working this way here. So it's -3 plus or minus the square root of, it looks like 17 over 4. So there you go. That's our other answer. And if you wanted to check, if you want to put this in as a decimal to check with your graph, feel free to do so. It looks like it's going to be these values, 0.281, and over here, -1.78. So you could always check that way too. But there's our three answers. We have 2/3 and a -3 plus or minus the square root of 17 over 4. So So rewatch this video again. This is the only example I'm going to show you because these take quite a while. So come with questions. We're going to do a few of these in class. Just to recap what we did, here are the steps. Recap the process. Feel free to write this down. The zero product property is when we set it equal to 0. So we either factor or we can factor it or whatchamacallit, use quadratic formula. Here we didn't have to do repeat synthetic division. We didn't have to do that step. But you keep doing that until you can get something that you can factor. Luckily, we could factor that using the T method or using the quadratic formula. So that was quite nice. All right. So that's all I have for you guys. Come with questions. We'll see you later.